So if you watch the videos on Pascal's triangle, this is an extension of that, how to use Pascal's triangle and binomial theorem to expand binomial cubed. So we'll start with the long version of the general form. And from grade 10 and grade 11, you should remember how to expand a binomial squared. X times x is x squared, x times y, xy, y times x, xy, y times y, y squared. Simplify 2xy plus y squared. And that is, if we look at Pascal's triangle, this is n equals 0, the exponent is 0, n equals 1, exponent is 1, n equals 2, n equals 3. This is n equals 2. We see the coefficients of 1, 2, 1. Other patterns, x squared, x to the 1, x to the 0. So the first the first term in the binomial, the powers are decreasing. The second term, y, the powers are increasing. 0, 1, then 2, y squared, right? So let's continue. X cubed plus x times 2xy, 2x squared y, plus xy squared, plus y times x squared y, plus y times 2xy, 2xy squared, plus y times y squared, y cubed. Again, simplifying x cubed plus, that should be 2x squared y. So 2x squared y plus 1x squared y is 3x squared y. Xy squared plus 2xy squared is 3xy squared, and plus y cubed. Again, take a look at all these patterns. Here's the coefficients: 1, 3, 3, 1. X cubed, x squared, x to the 1, x to the 0. Y to the 0, y to the 1, y to the 2, y to the 3. So all of those patterns are coming up in a expansion of a binomial cubed. Take this to a particular example. 3 plus x times 3 plus x squared. There's a reason why it's 3 plus x and not x plus 3. It doesn't matter, but you'll see later on. So 3 plus x, we'll do this the quick way. 3 squared plus x squared plus 3 times x times 2. That's that short form again from grade 10, grade 11. And then expanding the rest, 3 times 9 is 27. 3 times 6x is 18x plus 3x squared plus 9x plus 6x squared plus x cubed. 27 plus 18x and 9x is 27x plus 3x squared and 6x squared is 9x squared plus x cubed. Now the patterns aren't there as much. This is x to the 0, x to the 1, x to the 2, x to the 3. But otherwise, we don't see the same patterns in the coefficients, and that's because one of the terms was a number, so it kind of hides them. So let's take a look at this a different way. If we look at it like this, it's the Pascal's triangle coefficient times the first term cubed times the second term to the 0 plus Pascal's coefficient times the first term squared, decreasing in exponents, the second term. Notice how the exponents always add up to 3 because the exponent was 3, plus for the 1 x squared plus 1 times 3 to the 0 times x cubed. So 3 cubed is 27. 3 squared is 9 times 3 is 27x. 3 times 3 is 9x squared, and you notice that we get the same expansion as we got the other time, but a little bit quicker. And this is a lot of writing and a lot of work, but with a little bit of practice, you will find that you can actually use this to get to the end point pretty quickly.